Hey, so your scooter broke down. It won't turn on anymore. It doesn't run anymore. Damn, 300 euros down the drain. Hold on a second, because if you watch this video, trust me, I think you'll be able to fix this scooter with your own hands. Hi everyone, welcome back to the Wilson channel. Today we're talking about how to fix an electric scooter. Physically, I don't have an electric scooter here, but you should know that the first thing you absolutely have to do is start smoking, because if you don't smoke, you can't fix electric scooters. Forgive me, I'll finish my cigarette and be right with you. So folks, in this video, we'll see how a scooter is made, how it's literally built, and the main components that can break in a scooter. We'll take a look in detail, but not too much. So a quick, superficial overview of each single element to understand their parameters, how to fix them, and so on. And then we'll do a very basic diagnosis using the tools you have at home. Basically, guys, just know that when it comes down to it, you'll definitely need a tester. Nothing else, okay? A multimeter, you'll find the link in the description, or you can just buy one from the Chinese shops. So I'd say we can get started right away. Right, a scooter. I don't have a scooter, guys. I build electric skateboards. Don't believe me? I've got 3 dead ones right here under the table. I'll show them to you. No, you didn't believe me? 1, 2, and 3. 3 poor miserable bastards that I'm fixing up little by little. This board, guys, has almost the power of 125cc, just saying. Subscribe to the channel. Subscribe to the channel because, guys, on this channel, we talk about electronics in general. Yes, I also organize electronic music events, but mainly electronics in general, from building battery packs, which is why this table is a mess. And then go check out my series on how to build an electric skateboard. Maybe you'll find something useful there for scooters as well. Basically, it's the same thing. When it comes to components, they're pretty much the same. And that's exactly where we'll start with this video. The components of an electric scooter. Yeah, I don't actually have an electric scooter. Wait a second. Alexa Cinema. What's going on? There's a video about how my home cinema is set up. Go check it out. Now I'll connect my PC to the screen. And here we go, guys. No, hold on a second. And here is our electric scooter. So let me put on my glasses, otherwise this thing will blind me. So basically, fundamentally, you need to know one thing. Whatever type of scooter you have, whatever model it is, whatever brand it is, whatever it may be, it always has 3 components: battery, controller, and motor. You can add lights, there can be 2 motors instead of 1, there can even be a horn, turn signals, anything you want, but at the end of the day, the essential things that make the scooter move are the battery, the controller, and the motor. And at this point, let's continue this video by talking about each of these 3 parts individually, giving you a general idea of what they do, what they're for, and what could go wrong with them. Then we'll go on to diagnose issues among them, running cross-checks or not, depending on the situation. You'll always find the link to this thing in the description. Let's start with the battery, because now I'm going to grab a pointer too. The battery inside your scooter can be hidden either in the deck, so in the lower part down here, or inside the handlebar. It depends a bit, but you'll notice it right away. Usually when the handlebar is quite thick, the battery is inside it and the deck is slim. In other cases, if the deck is thick and the handlebar isn't round or has unusual shapes, it means the battery is inside here. And we're starting to talk about the battery precisely because it's responsible for basically 100% of the problems, or rather 95% of the problems always come from the battery. When your scooter stops working, doesn't turn on anymore, 99.5, 100% of the time it's the battery. All right, guys, I'll wrap this up. You get the idea. Alexa Cinema off. So now let's take a look at what a battery is made of, basically. Very broadly speaking, guys, and please, if you want, subscribe. In fact, just go ahead and subscribe. On my channel, there are many tutorials about building battery packs. How to do it, how they're named, how they're made, why one is better than another. I mean, just look at this mess I have on my workbench. Let me quickly set up everything again, because now I also need the overhead camera. We'll just give it a quick shot, and I think we're good to go. What beautiful hands. So we were talking about the battery, about how it's built inside, just quickly, right? A battery pack like this one is made up of many individual cells connected in series, in parallel, and so on. If you're interested, there's a video on the channel dedicated to the quick assembly of this battery pack. In that tutorial, there's a very quick and practical explanation of how it's built and how almost all batteries work. The fact is that once assembled, the battery looks something like this, where all the cells are arranged in a specific position and order to ensure it works as it should. And in addition, there's this board. Every one of our battery packs also has this board here. This board here is called a BMS. There are different types in various sizes, but for now, what you need to know is that the BMS is responsible for keeping your battery safe. It balances the charge of the cells, which, as we've mentioned, are either 18650 or 21700. Does that sound familiar to you? Anyway, the board and the BMS protect you from overcharging, over-discharging, various short circuits, and extreme temperatures. And if this board detects any anomalies, it can shut everything off either via software or hardware. And we'll get to that in a moment. Now, let's move on to the second component, the controller. Apologies, we had some technical issues with the microphone from the control room. We were talking about the controller. In short, guys, the controller is literally the brain of our vehicle. Basically, it receives input from our human commands, like the throttle on this remote control, or simply the gas knob you have on your scooter. Through that little cable, a signal is sent to the controller, and the controller converts that signal into the amount of power to deliver to the motor to make it run. The same goes for braking. Additionally, the controller itself manages all those things like the lights, the horn, the turn signals, as well as regenerative braking itself, meaning that when you brake, the energy is not so much dissipated as heat, but is instead mostly recovered and put back into the battery, basically. This is the hardest part to check if it's broken or not. In fact, as we'll see in the next section, the controller is basically diagnosed by a process of elimination. If the battery works and the motor works, then it's probably the controller that's causing the problems. Now let's talk about the last component, the motor of our vehicle. Okay, this is a motor for electric skateboards, but don't worry about that, because what really matters to us is the number of wires. Wires that, as in this case, and in your case, in the case of the electric scooter, will be 3 thicker wires, just like these, and a whole series of smaller wires. We can see that we have 6 of these smaller wires. Let's start right away by saying that the 3 thick wires are the ones that actually provide the power to make the motor run, while these smaller wires are part of the sensors inside the motor itself. In fact, as you can see in this image, there is a circuit board inside the motors. This circuit board has magnetic sensors that are responsible for checking that the current is distributed correctly among the 3 phases and for determining the exact position of the motor. And in addition, as in this particular case where we have 6 wires, there is also a thermometer on this circuit board. So it follows that out of the 6 wires, 3 are for phase detection, meaning for the magnetic sensors, 1 is for the thermometer, while the remaining 2 wires are for powering the circuit board inside the motor. And I would say that at this point, we can start by running some very basic diagnostics, of course, on our motor. How do we do this? First of all, let me tell you right away that if there's any issue with these wires here, so if the board inside is damaged or if the wires themselves are damaged, an error code will inevitably appear on your display. So in that case, you'll need to check online or in the manual to see what that error code means. And well, once you've figured it out, you've found your problem. In those situations, it's often better to just replace the motor because it will definitely cost you less than actually trying to repair it and find the right replacement part. Less effort, less time, trust me, and in some cases, even less money. So to recap, if the series of sensor wires has issues, you'll get an error code on the control unit and that's resolved, or rather, you've understood the problem. If the motor doesn't turn, there are basically 2 possible problems. The first, obviously, is a mechanical problem. If a bearing inside the motor has failed, it won't turn mechanically anymore. You'll hear strange noises and you'll need to replace the motor. If, on the other hand, the motor spins perfectly when unloaded, then we need to check the windings inside. It's a very simple process. We arm ourselves again with our multimeter, set it to the lowest resistance scale you have. So we're going to check the ohms, in this case on the 200 scale. And using the 3-phase wires, we measure them in pairs, all 3. So in this case, black and yellow, yellow and blue, and then black and blue. The resistance we should measure between all 3 windings of our motor should be similar, if not identical. If there is a significant difference, or if one of the 3 phases shows no resistance, it means that it is either broken or damaged. In that case, you also need to replace the motor. Let's look at an example. I checked the resistance between black and blue, which is about 0.4 ohms. I checked the resistance between blue and yellow, which in this case is also about 4 ohms. And finally, between black and yellow, where it should also be 4 ohms, and in fact it is. And by doing this, we've determined that our motor works and is perfectly rotating, functioning, efficient, and so on. So the problem lies elsewhere, either in the control unit or the battery. Let's go check the battery right away. For this part of the video, I'll give you an example with 2 identical batteries, meaning they are both 7S batteries, so with a nominal voltage of 25.2 volts. The first thing you should do is look for the label on your battery. In this case, I'm showing you on this battery because the other one is disassembled and its label is missing. Let's take a look, and somewhere there will be a line that says nominal voltage, in this case 25.2 volts DC. 25.2 volts DC will be the nominal voltage of our battery pack. Be careful, this is not a static voltage, it's not a fixed value because the battery can be charged or discharged. this process of discharging the battery results in a drop in its voltage. So, in the case of a 7S battery, where we have 7 cells in series, we will have a fully charged voltage of 29.4 volts and a fully discharged battery voltage of about 22 volts. The nominal voltage, the one we look for on the label, is simply a value that lies in the middle, an average value that identifies the main operating voltage of our battery pack. In the case of the 7S, that's 25.2 volts. What we should do now is once again take our tester, set it to DC voltage, 200 scale, and check at the terminals and connector of our battery to see how much voltage there is. Let's say that if we find a voltage below 20 volts or below 18 volts, it's already difficult to recover the battery. If the voltage is even lower, you've already found the problem. In that case, you'll definitely have to replace the battery. This is the damaged battery, I'm telling you in advance. And if we go and measure the voltage at its terminals, take a look, 0.6 volts. It's basically useless. You can't even try to recover this battery. Let's check the other one. I connect my tester leads to the 2 terminals, and in this case, we get a voltage of almost 24 volts, which means that this battery pack is still intact. Even if it had been 20 or 18 volts, we could have tried to recharge it by giving it, in the case of the 7S, 29.4 volts with a variable power supply at a very low current, like half an ampere, and leaving it there for a night or 2 in a row until little by little the cells would balance themselves out, and we probably could have saved our battery. In fact, when I recovered this battery, it was about 16 volts. By charging it very slowly, here it is, it's come back to life, and now we can use it again. But be careful, there might be a small catch. But then my scooter actually does turn on. It seems like everything works correctly, but when I accelerate, it turns off and restarts, or it turns off and doesn't turn on again. What could it be? You take apart your battery, check the voltage at the terminals. Do you have it? I'll explain it to you right away. This is where our little board comes into play, the board that protects us. What does this board do? Well, in some particular cases, especially when there are big scooter manufacturers who want to, let's say, create their own ecosystem, in quotes, their own internal circuit so that you can't use Chinese replacement parts but are forced to use their branded parts, here's what happens. Our protection board communicates with the control unit through a serial port, literally through a cable, okay? And if the control unit doesn't give the BMS permission to deliver power, then you'll find that, yes, it seems like everything is working. But when you actually need power to move forward and make the motor run, the battery won't provide it because it will be, so to speak, locked, not unlocked. So the BMS will only unlock once the control unit sends its approval. As a result, in this case, it would be the control unit that needs to be replaced. The control unit must have some defect or problem. We'll get to that in a moment, because in fact, the last step, the final part that makes up our electric scooter, is nothing other than its brain. And guys, there's not much you can do. When it comes to the control unit, without the proper tools and real knowledge, the only thing you can do is use the process of elimination. Then again, of course, it could just be that the throttle handle is broken. You could check if voltage is reaching it. You could use an oscilloscope to see if a PWM signal, a square wave signal in many cases, is coming back, which, when it comes down to it, is the input the control unit receives to understand how much throttle you're giving. But as mentioned, you already need to have an oscilloscope, which is, in quotes, a much more complicated tool to use than a simple tester. So what I recommend is that if the battery voltage is fine and the motor works properly, the control unit will inevitably have to be replaced by process of elimination. But there's always an alternative, finding a little button called a hard reset. In all control units, every single one, there is a hidden button somewhere. For example, in this case, it's not visible. You'll need to unscrew these little screws to find it, but there will definitely be a button on the circuit board inside here. This small, yet incredibly important button will simply perform a complete and thorough reset of all the control unit's current settings. And even if the manufacturer has deliberately put in some kind of protective lock for your battery's sophisticated battery management system, BMS, in theory, pressing that particular button will effectively remove it. However, the undeniable fact remains that your battery will still be completely locked because it doesn't receive the necessary authorization from the primary control unit. As a result, what I could do, but this would already be a job for real tinkerers, is to completely remove the BMS installed by the scooter manufacturer and replace it with a more generic BMS like this one, which definitely doesn't require any unlocking to deliver power. So guys, I really hope this video has been useful to you, that you've understood a bit about how scooters work. Or anyway, guys, even a Tesla basically works like this. So you always have a battery, a brain, and a motor. Every electric vehicle works this way. Of course, there are 1,000 differences between a scooter and a Tesla, otherwise the price wouldn't make sense. That said, I'll see you in the next video. And if you want to learn how to refurbish your battery pack, maybe by installing a non-proprietary BMS, you'll find everything here on the channel. There's a tutorial video for just about everything. subscribe, do it hereby.